So the next section is called the method of joints. So when designing a truss bridge, we really need to understand what type of loading is occurring in each of the members. So here we have a simplified truss, and let's say we know this angle here. We also know these dimensions. And let's call this point A. Let's call this point B. Let's call it point C, and we'll call this point B. And this is a pin assembly or pin support. This is a rocker support. And it's pinned right here. It's pinned. And let's also say that we have a load being applied at point B with the magnitude of force F in that direction. And we'll use our coordinate system with X being in that direction and Y being upwards. So again, what we want to do is be able to analyze the forces that these members are experiencing due to that load. One of the ways that we can do that is called the method of joints. And what that requires us to do is to pulling these pins out and drawing the free body diagram for all the parts. Pin at B, I will have my member, we'll call this A, we'll call this point B, and this is point A. And I'll also draw this member BC like this, and we'll call this BC. And I can also draw this member AC, and I'll draw it right here. We'll call this AC. And I can even draw the pin that was at C and the pin that was at A. So here's my pin A, and here is my pin C. We had said that each of these members are two force members. Therefore, I know the direction of the force at A and force at B. And I'm going to make an assumption that member AB, member AC, and BC are all in tension. So I will have F, let's call this B to A, and we'll call this F from A to B. And we know that they are equal and opposite in magnitude and collinear. Same thing with member BC. I know that the force at C and the force at B are equal and opposite, and I'm going to assume that the member is in tension. So we'll call this FBC, and we'll call this FCB. And same thing here for member AC. I know that the force here would be FAC, and the force here would be FCA. Now let's not forget that pin A was released from this pin support. Therefore, we have to now draw the effects of this pin support on pin A. That pin support prevented this pin from being able to translate in the X direction and also in the Y direction. Therefore, we have to draw the reaction forces in those directions. So I'm going to assume that this is AY, which is the reaction due to the pin support in the Y direction. And I'm going to assume that this is AX, which is the reaction force due to the pin support at A. We do the same thing for pin C right here. So at pin C, what we had was a rocker support, and that prevented the translation of pin C from moving downwards or translating in the Y direction. So I'm going to have a reaction force CY. That pin used to be at this joint where it connected member AC and BC together. Therefore, the effects of this force will play an integral part on pin C. And what I mean by that is there'll be a force FBC, or let's call it FCB, in that direction. The effects of FAC on pin C would be equal and opposite to it. So that would be FAC. Let's finish off the last pin here, pin B.